All right, now we're going to start with question 34 in our final review. Question 34, we start talking about chemical reactions and moles. All right, combustion. That is anytime you've got some, oops, I thought I was going to write with or type. Anytime you have something that is burning. Folks, this is something you should know. What are the products of combustion? Well, the products are carbon dioxide and water. Now we need to balance this. We have 2 carbons here, so I'm going to put a 2 there. I have 5 plus 1, 6 hydrogens, so I'm going to put a 3 here. I have 1 oxygen here, 2 there, but this one we can change easily. So let's count our oxygens on the other side. 2 times 2 is 4, plus 3 more, 5, 6, 7 oxygens. Here we have 1 oxygen plus a set that we can get to 6. 3 times 2 is 6 oxygens. 6 plus 1 is 7. That guy's balanced. Okay? If you need help with balancing equations, there should be some links to practice balancing on my webpage on the district website. All right, question 35. How many moles of carbon are in 0.5 moles of ethanol? All right, well, let's think about what we're talking about here. 1 molecule of ethanol. How many moles? You would have 2 carbons in 1 molecule. So if you have 0.5 moles of the molecule, and there's 2 carbons for each 1 molecule, you would have 1 mole of carbon. How many molecules of ethanol are found in 1.5 moles of it? 1.5 moles of ethanol. To find molecules, we have to multiply by Avogadro's number. 6.02 times 10 to the 23rd. I'll let you do the math because I don't have a calculator out on my deck where I'm sitting doing these. What is the molar mass of aluminum carbonate? Well, aluminum has a molar mass of 26.98. Carbon has a molar mass of 12.01, and there are 3 of them. Oxygen has a mass of 16.00, and there are 9 of them. So again, do the math. If you mix a 1/2 mole of oxygen with a 1/2 mole of CH4 and carbon dioxide and water produced, what would be the limiting reactant? Well, first we have to write the equation. CH4 plus O2 gives us CO2 plus H2O. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 2 oxygen, 2, 4, so we would need a 2 there. All right, we have a 1/2 mole of oxygen and a 1/2 mole of methane. Now, in class, I taught you a cheat way to do this. Divide by the coefficient. If we do that, obviously oxygen has less. So oxygen would be the limiting reagent. The reaction of 0.080 moles of C6H6 with excess HNO3 resulted in 6.8 grams of C6H5NO2 being produced. All right. Do we need to balance this? 1, 7, 5, 6, 7, 3, 2, 3. No, it looks like it's balanced. So we're going to start with 0.080 moles of benzene, and we want to know how much theoretically we should get of this compound, which is a nitrite of some kind. So we would take 0.080 moles and we would solve for C6H5NO2. It's a 1-to-1 ratio, so it's going to be 0.080 moles. We need to change that to grams. So 12 grams times 6 is 72, plus 5 hydrogens, plus a nitrogen, plus 2 oxygens. 5, 6, 7, 8, 9, 10, 11, 12, 13, 123. That will give me my theoretical yield. Which should be 12 grams, because I just did all the math and realized it's right there in the equation. How do we calculate percent yield? You take your amount, 6.8, divided by the theoretical yield, times 100, and you can do the math. Empirical formulas. This is the one we use the poem. Percent to mass, mass to mole, divide by small, multiply, tell whole. We've got something with nitrogen and oxygen. It tells us 73% is oxygen. That means nitrogen will make up the remaining to 100%. So 74 would be 26.8%, if I did my math right. First thing we do, percent to mass. Change these to grams. Next thing we do, grams to moles. Divide by 14. That's going to give us moles. 26.87 divided by 14.01. No, at 1.917. 73.2 divided by 16. 4.575. That's how many moles we have relative to each other. Now, it's always easier to balance if one of them is a 1. The best way to do that is divide by the smaller of the two, which will give us a something to 1 ratio. So that means, okay, this would give us a 1 to 2.4 ratio. We're going to round that to 2.5. So we would then use the last line of our poem, multiply till whole. We'll multiply them both by 2. That will give us N2. 2.5 times 205. So this would be N2O5.